Imagine a massive industrial factory, right? But instead of stamping out steel car parts or, assembling microchips, this factory takes in raw electricity and literally manufactures intelligence.
Right, yeah, it sounds like sci-fi.
It totally does. And now imagine that factory operates at a jaw-dropping 71% gross margin and just pulled in $215 billion in a single year. That is what we are looking at today. Welcome to the Deep Dive.
Glad to be here.
We're looking at a stack of documents from 2026, specifically NVIDIA's 2026 annual review and some recent tech coverage from the Straits Times. And our mission today is to help you, the listener, understand a fundamental shift in human history.
Yeah, and it really is fundamental. We're talking about computing moving from just a tool we use to this massive infrastructure that manufactures intelligence.
Exactly. And the hook here, the thing that just grabbed me immediately, is that revenue stat. NVIDIA's revenue surged 65% to $215.9 billion in fiscal 2026.
Which is just an astronomical number.
Right. With operating income hitting $130.4 billion. When you look at these numbers, the normal business metrics we use to measure tech growth just completely break down.
Oh, it breaks the entire model. I mean,
Right.
we're so conditioned to look for, the incremental smartphone update or a clever new app feature.
Mhm.
But those numbers tell a completely different story. This isn't just an upgrade cycle. It's a total platform shift.
How big of a shift are we talking?
Honestly, we are essentially watching the largest computing reset since IBM introduced the System 360 mainframe back in 1964.
Wow.
Yeah. It's a complete reinvention of the entire computing stack, from the concrete on the data center floor all the way up to the software you interact with.
Okay, so to understand how one single company pulls those kinds of numbers, we have to look at what they're physically building. And the 2026 documents make a massive point of moving away from the term data center.
Right, they don't even use it anymore.
No, they explicitly call these new facilities AI factories. And look, I think a lot of people might hear that and just write it off as marketing spin.
Sure, it sounds like corporate branding, but it is actually a very precise description of the thermodynamics and economics at play here.
How so?
Well, for most of history, software was static. The developer wrote an algorithm, and a data center essentially functioned as a giant digital filing cabinet.
Like a digital library.
Exactly. You just stored those pre-recorded rules and served them up when you requested them. But an AI factory doesn't do that. It takes raw materials, massive amounts of data and electricity, and synthesizes something entirely new in real time. Software is actually trained now, not just written.
So if you're pulling a 71% gross margin on manufacturing intelligence, your limitation is just how fast your factory floor can run.
Precisely.
I want to get into the actual mechanics of that for you listening. If the old data center was a digital library, how exactly does an AI factory physically convert a megawatt of raw power into a digital token?
The best way to visualize it is as an incredibly dense energy pipeline. You're piping megawatts of raw electrical power into these sprawling clusters of interconnected GPUs. And unlike the old CPUs that process things sequentially, these GPUs are crunching massive, multidimensional neural networks simultaneously. So they are taking that electricity and turning it into computation.
Right.
And that computation outputs tokens. And since tokens are the raw materials of AI, fragments of data, images, logic, you can see how the core economics shift. The whole game is throughput per megawatt.
Ah, so how many tokens you can manufacture for every watt of power you pull from the grid?
Exactly. That defines your production. And conversely, cost per token defines your efficiency. It is exactly the same financial model as a power plant turning coal into electricity, except here we're turning electricity into applied reasoning.
That makes so much sense. And it explains why they are so far ahead. But if you're building these AI factories, you need the heavy machinery to fill them.
Yeah, it's the chips.
Right, the hardware arms race. And the pace here is just mind-bending. The documents talk about the success of the Blackwell Ultra platform.
Yeah.
It delivers 50 times higher throughput and a 35 times lower token cost than the previous Hopper generation. 50 times. You'd think that alone would dictate the market for years.
You would think so, yeah. But the CES 2026 announcement by CEO Jensen Huang just blew right past it.
That's the part that's so crazy to me. He gets on stage and says the new Vera Rubin platform is already on track.
All 6 chips are back from the manufacturing partners.
And the specs are just wild. 3.5 times better at training and 5 times better at running AI than Blackwell. It's got an 88-core CPU baked in with twice the performance.
And crucially, the Rubin systems will actually be cheaper to run.
Wait, how does that work? How is it cheaper if it's that much faster?
because they require fewer components to get the exact same results. By hyper-integrating everything, they reduce the physical distance data has to travel. Less networking overhead means less power wasted.
Okay, wait. I have to push back on this timeline, though. Because Blackwell just transformed the industry, right? And they are already rolling out Rubin. How can the industry even absorb hardware this fast without all those older billion-dollar chips becoming instantly obsolete?
That's the multi-billion-dollar question, right? But NVIDIA anticipated this, and their answer is
Right.
basically the fortress surrounding their empire. It's a programming model called CUDA.
CUDA, right.
Yeah, CUDA is a software mode. It ensures backward compatibility. So developers write their applications for the CUDA platform, not the specific physical chip.
Oh, I see. So it extends the lifespan of older systems.
Exactly. Developers can keep building without fear of instant obsolescence. A Blackwell chip doesn't become useless when Rubin arrives. It just shifts down the compute hierarchy to handle slightly less demanding tasks.
Got it. Okay, so with all this unprecedented computing power from the Rubin chips coming online, what exactly are we asking these computers to do?
Well, there's a massive milestone in the annual review about exactly that. Inference has officially overtaken training as the dominant workload.
Okay, explain that. Inference meaning like running the models to get answers.
Exactly. For years, the bulk of the power went into training the models, basically teaching the brain. But now, the power is going toward actually putting them to work. And that brings us to the rise of agentic AI.
Agentic AI. This is a huge theme in the coverage.
Right, because AI no longer just answers questions. It perceives, it reasons, it plans, it uses tools, and it acts.
Which is wild. And NVIDIA views this AI ecosystem as this, they call it a 5-layer cake.
I love that analogy.
It's super helpful. So you've got energy at the bottom, then chips, then infrastructure, then models, and at the very top, applications.
Right?
But look, if I'm a business owner, I just want the frosting, you know, the application layer. But it sounds like NVIDIA is saying you can't have the frosting without buying the whole bakery. Is that right?
That is exactly right. Every successful app pulls on every single layer beneath it, all the way down to the power plane.
But why? Why is it so heavy?
Because of reasoning. These new agentic reasoning models require so much more compute because they generate what are called thinking tokens before they ever answer you.
Wait, thinking tokens? Like they talk to themselves?
Essentially, yeah. They internally evaluate pathways, check their own logic, discard bad ideas. All of that takes massive, continuous compute power. That's why inference is driving cloud demand so hard.
Wow. Okay, so if we have SoftBank CEO Masayoshi Son predicting a future with 100 trillion AI agents making decisions and communicating with each other.
100 trillion. It's hard to even wrap your head around.
It really is. But once you have that many agents capable of reasoning and planning in the digital world, the next logical step is leaving the screen, right? Giving them a physical presence.
Yeah, the ChatGPT moment for physical AI has arrived.
And the financial proof is right there in the 2026 documents. Nvidia generated $6 billion in physical AI revenue.
Real money, not just R&D.
Real money. We are seeing real-world applications right now. Mercedes-Benz has L4-ready vehicles. There's an Uber partnership for the world's largest autonomous mobility network. Factory robotics everywhere.
It's all moving so fast because it's powered by an ecosystem of nearly 3 million open models.
Yes. Let's talk about that, because NVIDIA has these open models. Nemotron for agents, Cosmos for physical AI, GR00T for robotics, BioNeMo for biology.
Right. They allow developers to basically customize intelligence for whatever specific need they have.
But I have to point out the irony here. It's glaring.
Oh, I know what you're going to say.
They're selling the most expensive hardware on Earth, but they are literally giving away the model architectures for free to millions of developers. What is the catch here? Why do that?
It's brilliant, honestly. Open models significantly lower the barrier to entry for developers.
Okay.
So when developers can build and deploy applications for free, what happens? Token generation explodes. There are suddenly billions of tokens being generated every second. And as we established earlier, more tokens mean more demand for compute throughput, which means more demand for NVIDIA's hardware. They give away the software to create an insatiable demand for the physical ovens required to bake the tokens.
That is wild. Okay, so that brings us to the $5 trillion question.
Let's hear it.
We've established that AI is moving into the physical world. It requires this massive 5-layer infrastructure, and it's happening at light speed. But this takes an unimaginable amount of money and power, which forces us to ask, is this economically sustainable? Or is it a bubble?
Well, SoftBank's Masayoshi Son has some strong thoughts on that.
He does. He claims AI will need $5 trillion in investment. Or, for context for the Straits Times coverage, that's about 6.5 trillion Singapore dollars.
Every single year by 2040.
Every year. And he calls any talk of an AI bubble absolutely absurd.
Look, it's an unprecedented amount of capital. But the energy demands alone dictate that scale. It's completely reshaping economies.
Yeah. The documents talk about the creation of hundreds of thousands of skilled trade jobs. We're talking electricians, pipe fitters, working right alongside the software engineers.
Because you have to physically build the factories and the power grids to support them.
Which actually brings up a really important tension in the sources. There was a stockholder proposal asking Nvidia to disclose the greenhouse gas emissions from the end use of their products. Now, just to impartially report what's in the text, the board recommended voting against that proposal. We are not taking sides on corporate governance or environmental politics here.
Right, absolutely not.
But we bring it up because it perfectly highlights the sheer tension of this moment. You have the massive energy requirements of this AI build-out colliding head-on with external environmental pressures.
It's the physical bottleneck of the AI revolution.
But going back to the money, $5 trillion a year, that is not a tech budget. That is the GDP of a major country. Are we sure the return on investment is actually there to justify this?
It's a great question, but the ROI debate was largely settled in 2026.
Really? How?
Because the agents are now doing useful work. They aren't just parlor tricks. They are coding, they are designing, they are discovering new drugs. Compute is no longer viewed as a cost center to support software.
Right.
It is a productive asset. It's labor. And that labor generates massive revenue.
Okay, wow. So wrapping this whole journey up for you listening, we have gone from data centers just storing files in digital cabinets to Blackwell and Rubin chips powering these massive AI factories.
And we've seen inference take over, with autonomous agents stepping off the screen and into the physical world.
All driven by a multi-trillion-dollar economic engine that is fundamentally changing what labor even means. Which leaves us with one final provocative thought to ponder from the source text.
This is from the CEO's letter, right?
Yeah. He makes this fascinating distinction between tasks and purpose. He explicitly states that, quote, coding is a task, innovation is the purpose.
It's a powerful distinction.
It really is. So here is our final thought for you to explore on your own. If we really are heading toward a future with 100 trillion AI agents, and they eventually automate almost all of our daily tasks, how will you redefine your own purpose? In a world where human intelligence and keystrokes are no longer the primary bottleneck for getting work done, what becomes your core value?
It's something we're all going to have to figure out.
Absolutely. Thanks for joining us on this deep dive.